So free response, topic number 2, graphical analysis. Again, all 3 are assigned today. In the future, that may or may not be the case because we have tons of old problems and we don't need to do all of them. As you're working these at home, remember that they're basically allotted 15 minutes per free response question, so you can kind of keep an eye on time. We can see what the time is on this video right here because I started it. So we'll see if we can finish number 1 in 15 minutes or less. Don't worry that these say BC because there are overlap questions that are on the AB test and the BC test, right? BC covers a little more than we do, but that means part of their test is identical to your test. And so I've only pulled the questions that would be AB topics. And in fact, this doesn't really apply to you, but to show how much overlap there is, BC students, when they take the BC test, they get 2 scores. They get a BC score and they get an AB subscore. So like kind of shows that if they did well on the AB stuff but not the BC stuff, they can still get, an AP grade of a 4, an AB grade of a 4, even though their BC grade is a 2 or whatever. So there's a lot of overlap. All right, number 1. The graph of the continuous function g, the derivative of function f, is shown. Well, that's kind of a weird way to say that. So this is g that's shown, but g is the derivative of f. So we're going to need to be real careful here. That's the graph of g, but g is f prime. The function g, so the graph, is piecewise linear between -5 and -3. Or no, -5 to 3 is all lines. Okay, that makes sense. And then from 3 to 6, it's that parabola. Okay, I think I got the setup now. If f of 1 is 3, what's the value of f of -5? Well, I don't have a picture for f. I have a picture of f prime. How do I get from f prime back to f? Integrate. So if, maybe up here, by the way, on the actual AP test, 1 free response question is spread out over like 2 or 3 pages. So you'll have like half a page to work part A, half a page to work part B. So you'll have plenty of room. So if we integrate both sides, so the integral of g is equal to f, but I probably need some limits on there. So what should I use for my upper and lower bounds, upper and lower limits? My x values that I know. So I'm going to go -5 to 1. So that means f of 1 minus f of -5. -5 to 1, because those are the x values that I have. Should have done this on a separate page to get from the start here. So the integral of g from -5 to 1 equals f of 1, which we know, minus f of -5, which is what we're looking for. So if I can get the integral from -5 to 1 of g, I'll have everything I need on this problem. Well, the integral from -5 to 1 is the area under g. From -5 to 1. So let's just divide it up. That would be -9. This little area would be 3 times 1 over 2, so negative 1.5. And 0, and then 1. F of 1 is 3. F of negative 5 is what we're looking for. So now I just need to move things around a little bit. Let's see, negative 10.5 plus 1 is negative 9.5. So F of negative 5 then is 3 plus 9.5. And I'll be lazy and leave it like that just to make the grader work for it a little bit.
I'm sorry, how did you get over?
Good on that part? Evaluate the integral from 1 to 6 of g of x. Okay, well I feel like we kind of just did part of that, right? No, we did negative 5 to 1. Now we want to go 1 to 6. Uh-oh. How am I going to go from 1 to 6? The area under this thing. Well, I think we need to divide it up here. From 1 to 3, the area is 4. So I'm going to do the integral from 1 to 3 plus the integral from 3 to 6. Because from 1 to 3, that's just a square. That's 4. From 3 to 6, I have to switch over and not think about area. Well, I mean, I am thinking about area, but I'm going to have to use this equation. Whoops. X minus 4 squared dx. So I'm going to have to, yeah, that's not just counting squares anymore. What's the easiest way to do this? I think I'm going to put the 2 out front. And probably my best bet is to just do algebra first on this, rather than, I mean, I can do it without doing that, but I think that's the easiest way. Don't forget the 4 that's still out front. So x cubed over 3 minus 4x squared plus 16x from 3 to 6. This was on the no calculator form, but we have a safe stop, so I'm going to plug in 6. And then plug in 3. And call it a day. Right? I don't want to mess with that. And they don't want you to mess with that. They want, like, you've shown all the calculus. We're good here. Don't spend precious time doing 6 cubed divided by 3 and all the other parts of that. Like, get it set up. You've done the calculus. You've shown you know what's going on part B there, so we're good. Part C. For x between negative 5 and 6, so way over here, on what open intervals, if any, is the graph of f both increasing and concave up? Okay, so f is increasing when f prime is positive, f is concave up, and f double prime is positive. Reason for your answer. Okay, so I'm working on my reason right now. My graph is f prime. So where is on 5 to 6 f prime is positive just from the graph. It even said open interval, so I'm not worried about do I need to do the brackets or parentheses. It told me to use parentheses. Oh, negative 5 to 6. Okay. I was thinking that was too easy. So f prime is positive. Open interval, so I'm not really even worried about the 4 there. Well, maybe I need to be careful here. So 0 to 4. Although if this thing is continuous, it levels out at 4 for a moment and keeps going, then it's 0 to 6. So f prime is 0 at 4, but it's increasing on either it's increasing on either side of it. So it's increasing the whole way. F double prime is positive. Well, I don't know about f double prime, except that if I take the derivative of both sides, that means I need g prime to be positive. So I need the slope of g to be positive. That would be from 0 to 1 and 4 to 6. So where both of those things are happening would be from 0 to 1 and 4 to 6. Oh, I guess the slope of g is also positive from negative 2 to negative 1, but I'd already decided I wasn't going to look there anyway because I needed f prime to be positive. Part D. And the bell should be ringing right now. Point of inflection for the graph of f. So that means f double prime changes signs. That means g prime changes signs. So the slope of g changes signs at x equals 4. And that took us 15 minutes, so we're right on track. All right, so you try the other two. We'll go over them tomorrow.